Oke, aku start ya. Right, good evening, everyone. So now it's our turn to do presentation about smart blind stick with VL53 L1X time of flight sensor. So let me introduce my team. Here we have electrical and mechanical. Um, me, Nur, Yusuf, Sarah, Ilham, Riyad, Haikal, Arnold, Steven, Reno. Hmm, yeah, okay. So the PPT structure here, we're gonna explain about the context, the IPO, knowledge depth, and literature findings. Okay, so you might ask, so why do smart blind stick exist in the world? So usually for the visually impaired people might using blind stick, traditional blind stick. So here we make a improved version of a smart blind stick that contains or consists of time of flight sensor. So one of the group that requires special attention is people with visual impairments that included in the journal link number 1. And then the second one and the third one is explaining about why electronic cans are better than traditional cans. Okay, next
Okay,
slide. Yeah.
okay, next I will explain this slide, the stick slide. This slide shows the disability trend from 2021 to 2025 based on DP data. The graph shows that the number has fluctuated over the years, highlight the continuous need for better support for people with disabilities. Visually impaired people in Indonesia still face challenges such as limited access to education, employment opportunities, and public facilities. Therefore, our smart buying stick is designed to help improve their safety and independence. Next.
Okay, the slide before this, we talk about why technology is important to help blind people. As technology keeps growing, blind stick also changed from traditional can into a smart stick with modern feature. So in this slide, we can see the development of blind stick technology and the percentage of user for each type. Traditional can are still the most used because they are simple and cheaper. Our modern smart blind stick already use sensor, GPS, GSM, and microcontroller to give better safety and assistance. Our project is include a modern technology because we use ESP32, VL5, 3L1X sensor, GPS, GSM, and other smart feature.
Okay, so I will explain about conventional compared to smart blind stick that we'll make. So our smart blind stick consists of a TLF sensor, which is the sensor must comply with a basic electronic safety, including battery and the assistive device directory, because the visual impaired people could not see the surrounding objects and detect anything, so we will adding up smart infrared firing to the object within 4 meters. And for the stability, smart blind stick is much more stable than conventional blind stick, of course, because there is object control. And for the accuracy, our smart blind stick is higher accuracy due to sensor existing, and then obstacle detection is long range, multi-direction, and audio control. So feedback type navigating, we're using a smart GPS here. So when the visually impaired people is lost during he or she want to get back home or whatever, so there will be location sending um to their parents or something close to get a GPS notification to track the visual impaired location. So what about the use? So of course, smart lensing needs some slight learning curve, but it does not difficult to learn because just consists of um, one button and automatic object reading. For the maintenance, we require battery changing and charging too, and also electronics maintenance. For the cost, smart blend stick is higher cost due to electronic components, but for advantages, of course, it's more than conventional blend stick. For the failure risk, quite moderate for the developer or the engineer who build the smart blend stick. So it's us. So it's moderate level of risk to us for handling. Okay, next. Okay, so I'm gonna explain the main concept here of VL Future L1X. So we can imagine we're standing in the cave, and when we shout in the cave there, our voice or our echoes will travel surrounding the cave. And then the further away the world are, so the longer it takes to echo to the return. So this concept is exactly same applicable for PL53L1X smart blind stick sensor, but here just using infrared lights to firing object. Okay. Okay, next slide will be presented by Ilham.
Oh, okay. VL53L1X system proceeded. Uh, the system is actually the same. Uh, like source, laser, and detector receiver. This is object distance calculation for uh, from the time taken for like travel, closer to reflection time of like PL what's sensor.
Okay, I will continue the presentation. Okay, I will explain why we choose the HCSR04 ultrasonic sensor for our simulation. The actual smart blind stick used the VL53L1X sensor, which measure distance using laser light and time of flight principles. However, the sensor is not available in Walk B. Therefore, we replace it with the HCSR04 ultrasonic sensor. Although it uses ultrasonic sound waves instead of laser light, it works in a similar way. The ESP32 sends a trigger signal. The HCSR04 emits ultrasonic hitting an obstacle, and the sensor calculates the distance based on the echo travel time. Because both measure distance using the travel day of a signal, the SCSR04 is suitable substitute for the simulation. So why we choose the HCSR04? Because it's a follow a similar distance measurement principle, and it is supported by Walkway, allowing us to test and validate our system successfully. Thank you.
Please, next slide.
Uh,
Uh,
okay.
Thank you. Thank you. I will explain slide. This is slide. This is actual wiring versus simulation. Since some components are available in Walkway, we use close substitute for simulation. For example, the VL53L1X top sensor are represented by HCSR4 ultrasonic sensor, and the DF player with speaker is replaced by a simple buzzer, the GPS and GSM model, which need real network signal or simulate serial monitor output instead. The core logic and ESP32 control system remain identical between the simulation and actual hardware. Next slide.
Uh, okay, now I will explain the simulation wiring of our smart blind stick. The core of the system is the ESP32 microcontroller, which processes all input and outputs. For the inputs, we use three HCSR04 ultrasonic sensor placed at the left, center, and right position to detect obstacle from three angles, and LDR sensor to detect ambient light condition, and an RF receiver and transmitter on wristband for the fine stick feature. For the outputs, when an obstacle is closed or the tracking button is pressed, the ESP32 activates the buzzer and LED to give sound unlike alerts. For the simulation, layout ensure all components work together before we move the actual wiring. Thank you for attention.
Okay, here we can see the wiring system of the smart blind stick. First, the power supply use a battery that can be recharged with a battery charger module, and the voltage is then boosted to 5 volt to properly power the SP32. When the system is turned on, the speaker gives a sound notification. Okay, next slide.
Okay. On this slide, we can see the wiring system of the smart blind stick. The main control is the ESP32, which connect and manage all component. Uh, we use three PL53L1X sensor to detect obstacle from different direction, improving safety and accuracy for the user. The LDR and LED work together for night mode. So the stick can automatically provide lighting in dark environment. The RF receiver allows communication with the bracelet locator feature, helping user find the stick easily. For emergency situation, the GPS and GSM modules can send the user location through SMS. And finally, the flyer modules provides audio feedback warning to assist visually impaired user during navigation. Thank you.
Okay. This figure show the wiring design of the bracelet system. The bracelet function is a supporting device that help user locate the smart stick when it is not nearby. The system consists of TP 4056 battery charger module, recharger battery push button, resistor, transistor module. The TP4056 module is used to charge and manage the battery safely, while the battery supplies power to the circuit. When the user presses the push button, the transmitter module becomes active and sends a wireless signal to smart joystick. After retrieving the signal, the stick active a sound output through the buzzer or speaker, making it easier for the user to locate it. Overall, this bracelet provides a simple and practice solution to improve user confusion and reduce the risk of losing the stick. Okay, next.
Okay, that's all for our presentation. We open for 3 questions.
Okay, so I have a questions. So from what I understand, your system only detects the distance from obstacle, right? So why didn't your team implement object recognition using AI or even a camera?
Okay, thank you for the question, Amanda. Our main
objective was to develop a reliable and cost-effective mobility aid. So, integrated AI vision will significantly increase computational requirements, power consumption, and overall system costs. Therefore, we prioritize obstacle detection reliable over object classifications.
Okay, thank you. That answered my questions.
Next questions.
Okay, my question for design trade-off. Your system use only one distance sensor. Why didn't you install multiple sensor to eliminate blind spots?
Okay, thank you, Intan, for your question. So, um, we using multiple sensor will improve obstacle coverage, but also increase hardware complexity, power consumption, and cost. For this prototype, we prioritize simplicity, affordability, and sufficient performance for everyday users. That's all for the answer for your question. Thank you.
Thank you, Bang Steven.
Okay, I want to ask about your project. If the sensor suddenly fails during operation, how will the user know that the system is no longer functioning properly?
Okay, thank you for your answer, Dr. Stephen. Currently, our prototype does not include sensor fault detection mechanism. In future development, we plan to implement a self-diagnosis feature that can detect sensor failure and immediately notify the use stroke vibration or audibly alert. Thank you.
Okay, thank you for your answer, Bang.
Okay, that's all for our presentations. Good evening, guys. Thank you for attention.
Good evening, Carol. Thank you.
Good evening.
Thank you,
Thank you.
guys.
Ilham.
Matikan slide-nya.
Ini kerekam nggak ya?
Matikan,
Ini
matikan.
masih rekam ya?
Nah, matikan recordnya.
Tiba-tiba nggak ke